Power rating of a resistor. The power rating of a resistor is the maximum power the resistor can safely dissipate without too great a rise in temperature and hence damage to the resistor. Part A. If the power rating of a 15 kilo ohm resistor is 5 watts, what is the maximum allowable potential difference across the terminals of the resistor? Now, the maximum power that can be delivered to this resistor is related to the potential difference maximum value V max squared divided by the resistance R. So this means the maximum voltage that can be applied across this resistor is its resistance multiplied by its power rating inside the square root. So plugging in the numbers here, the maximum voltage is, because it's a 15 kilo ohm resistor, 15 times 10 to 3 ohms times power rating 5 watts square root. This gives us a maximum voltage of 274 volts. All right. Part B. A 9 kilo ohm resistor is to be connected across a 120 volt potential difference. What power rating is required? Well, in this case, we know the maximum voltage. We want to find the power rating. The maximum power it can handle is, once again, maximum voltage squared divided by R. So this is the maximum voltage, this is the maximum power it can handle. If I plug in the numbers, the maximum voltage is 120 volts, so it's 120 squared divided by the resistance 9 kilo ohms, 9000 ohms. So this gives me a maximum power of 1.6 watts. Part C. A 100 ohm and a 150 ohm resistor, both rated at 2 watts, are connected in series across a variable potential difference. What is the greatest this potential difference can be without overheating either resistor, and what is the rate of heat generated in each resistor under these conditions? So I have R1 equals 100 ohms, R2 equals 150 ohms connected in series with a variable voltage source. The maximum power each resistor can handle is the maximum current squared times the resistance. So for the 100 ohm resistor, this implies that the maximum current it can handle is, because the power rating is 2 watts, 2 divided by 100 square root, and basically I'm using I max equals square root of P max over R, the resistance. So for the 150 ohm resistor, this will imply the maximum current it can handle to be square root of 2 divided by 150. All right. Now the maximum current that can flow in this circuit will be the minimum of these two maximum currents. Otherwise, one of the maximum currents will be exceeded and the resistor will burn. So it will be permanently damaged. So the actual maximum current that can flow in this circuit is the minimum of Imax 1 and Imax 2. So which one is smaller? Obviously, this one is smaller. So we can find Imax to be square root of 2 divided by 150. The maximum current that can flow in this circuit is 0.115 amps. Okay. Then the power dissipated by the first resistor, P1, will be Imax square R1. So this will be 2 divided by 150, that's Imax square, times its resistance, 100 ohms. P1 is equal to 1.33 watts. And P2, the power dissipated by the second resistor, will be equal to Imax squared R2, and this will be P2 is equal to 2 divided by 150 times 150. That's basically the power rating of the two resistors, which is 2 watts. Now you can see that the power dissipated by the first resistor, it has to be less than its power rating. So P1 has to be less than or equal to 2 watts. And indeed, this is the case. So this resistor will not be damaged. Now, the question was, what is the greatest potential difference that can be applied without overheating the resistors and the rate of heat generated in each resistor? The rate of heat generated in each resistor is P1 and P2. Now, what is the maximum voltage that can appear across these two resistors connected in series? Maximum voltage is the maximum current multiplied by the equivalent resistance R1 plus R2. So I will find that the maximum voltage is square root of 2 divided by 150, the maximum current multiplied by 150 plus 100 ohms. So it will be, so this is the maximum voltage, and the numerical value will be Vmax equals 28.9 volts. Okay, so in this problem we're talking about power rating of resistors. Power rating means it's the greatest power that can be dissipated by the resistor without getting a too much increase in temperature and a permanent damage. So knowing the power rating of a resistor, we can calculate its maximum voltage we can apply, because maximum power is Vmax squared over R. Or knowing the maximum voltage, we can calculate the maximum power it can handle through Vmax squared over R. If two resistors are connected in series with the same power rating, 2 watts, the maximum current that can flow in the circuit without causing a permanent damage to either of the two resistors is the minimum of the maximum currents each resistor can handle. So we can see that if the power on the resistor R1, power dissipated by R1 is 2 watts, then the current will be too high for R2 and it will be permanently damaged. So we choose the minimum of the two maximum currents, which is found by looking at Pmax equals Imax squared times R and calculating the maximum current that each resistor can handle. So once we choose the maximum current that can flow in the circuit, we can calculate the power dissipated by the first resistor is Imax 2 squared times R1, which is the maximum current that can flow in the circuit, and P2 was basically found by the power rating anyway, so it is 2 watts and 1.33 watts, the rate of heat generation in these two resistors. Now, once we know the maximum current and we have the equivalent resistance R1 plus R2, we can calculate the maximum voltage as I max times R equivalent, which is 28.9 volts.